Hello and welcome. In this video, we will learn about the polar representation of complex numbers. So we have a complex plane having real and imaginary axes, and let us have a point P in the complex plane representing the complex number z equals to x plus iy. The real component x of this complex number is shown on the real axis, and the imaginary component y of this complex number is shown on the imaginary axis. Now let us have a line from O, origin of the complex plane O, to point P, and let us call the length of this line OP as R. The value of R is equal to the modulus of complex number Z, which is given by R equals to x square, square root of x square plus y square. Now let us assume that the line OP makes an angle theta with the real axis. Then in terms of r and theta, we can write the real component and imaginary components x and y as x equals to r cos theta and y equals to r sin theta. Using these values of x and y in this complex number z equals to x plus iy, we can write z as r cos theta plus I sin theta. Thus, we are able to represent the complex number z in terms of pair of real numbers r and theta. This pair of real numbers r and theta is called the polar coordinates of point P, and this representation of the complex number is called the polar representation of the complex number z. The origin of the complex plane is the pole of the complex number z. Now let us take an example. In this example, we will write the complex number z equal to 1 plus square root of 3i in the polar form. So we can write the real component 1 equal to r cos theta and imaginary component root 3 equal to r sin theta. Then we can square and add these two equations to get r square times cos square theta plus sin square theta equal to 1 square plus root 3 square. This is equal to 4. Now cos square theta plus sin square theta is 1. Therefore r square is equal to 4 and r equals to 2. We have obtained a value of r as 2. Now we can write the real component as 1 equal to 2 cos theta and the imaginary component as root 3 equal to 2 sin theta. From these two we get cos theta as 1 by 2 and sin theta is root 3 by 2. Both these two equations give the value of theta as pi by 3. Value of theta is obtained from this equation as pi by 3. Then using the values of theta and r, we can write the complex number z as 2 times cos pi by 3 plus I times sin pi by 3. So this is the complex representation. This is the polar representation of the complex number z equals to 1 plus square root of 3i. So in this video, we have learned about the polar representation of complex numbers. In the next video, we will learn about the complex solutions to quadratic equations.